right, my kiddos, today we're going to cover lesson 312 called the inner transition metals. The inner transition metals have a special place on the periodic table. The two rows of elements at the very bottom of the periodic table are the inner transition metals. And typically you see them right here at the bottom of the periodic table. There are two rows of inner transition metals. The first is the lanthanide series, and this series starts with the element lanthanum, La. It includes the elements with atomic numbers 57 through 70. The second row is called the actinide series. It begins with the element actinide and includes elements with atomic numbers 89 through 102. Depending on the periodic table that you're looking at, though, some periodic tables will include elements 57 through 71 and 89 through 103. We pull them out of the periodic table to make the periodic table fit on a regular piece of paper, but normally they would be right here. So this bottom row would fit right up in here, and if you use an extended periodic table the way it's supposed to look, this is where they would be right here. But we pull them out and put them at the bottom of the periodic table to make the periodic table fit on a normal piece of paper. And if you notice here, they're also called the F block elements, because if you did the electron configurations for all of these elements down here, their electron configurations would all end with an F orbital. The inner transition metals are sometimes referred to as the rare earth metals. At first, chemists classified the inner transition metals with the other transition metals. The early chemists soon found that the elements we now classify as inner transition metals did not share the same properties as those other metals. They had their own set of properties. In many texts or websites you may take a look at, you may see the elements of the lanthanide and actinide series referred to as the rare earth metals. This is an old term that is deceiving. Some are quite common. Cerium is the 25th most common element on Earth. Like most metals, inner transition metals are usually found in minerals and mined. In the case of uranium, it is then refined into a powdery cake, as seen here in this picture. Inner transition metals have their own physical and chemical properties. One of the interesting things about the inner transition metals is that these elements are so similar in properties that they are often hard to tell apart. The inner transition metals are typically silvery white or gray in color. They're very shiny and react very easily with the air, resulting in explosions or tarnishing. These metals are very good conductors, and the inner transition metals also react very readily with nonmetals. Elements 93 to 102 do not exist in nature. These are what are called transuranium elements. Scientists produce these elements in laboratories using nuclear equipment and particle accelerators. The transuranium elements are radioactive and decay rapidly, and thus do not exist naturally on Earth. The most well-known of these elements is plutonium. Samarium is an element in the lanthanide series. The lanthanides are soft, silver-colored metals. They are reactive. They'll tarnish quickly when exposed to the air, and will even react with water if given enough time. Samarium has an atomic number of 62. Samarium, like many other metals in the lanthanide series, has commercial applications. It's used in nuclear reactors and in lasers. When combined with cobalt, it makes very strong magnets, and a radioactive isotope of samarium, samarium-153, is used in medicines to treat the severe pain bone cancer patients may experience. Europium, which you can see in the picture there, is another lanthanide series inner transition metal. Europium is an inner transition metal with the atomic number 63. It was discovered in the 1890s and was named after Europe. Europium is the most reactive of all the inner transition metals. It reacts with water quickly. Europium is also very ductile, which means it can be drawn out into wires. Europium has few applications. Some forms of europium are used in electronics, such as televisions. It can be used in procedures to test for Down syndrome and other conditions during prenatal exams. Europium, like the other intertransition metals, is not found as a pure element in nature. It is found in minerals such as monazite. All elements of the actinide series, the bottom row of the F block, are radioactive. Out of the 14 elements in the actinide series, only thorium and uranium occur in nature in any significant quantity. Actinium and protactinium are found in only trace amounts, and the majority of the elements in the actinide series are transuranium elements. Recall that this means that they are only produced in the laboratory. So transuranium means everything after uranium. Uranium is number 92, so 93 and up would be your transuranium elements. Actinide series elements have nuclei that are so large that they tend to break down, and all actinide elements experience natural radioactive decay. Uranium is a well-known element in the actinide series. It's an intertransition metal with the atomic number 92. Uranium is found in nature in the form of 3 different isotopes: uranium-238, uranium-235, and uranium-234. It's found in the water, soil, and rocks on Earth. It does not exist by itself, but is found in minerals such as uraninite, lignite, and monazite, and in phosphate deposits. Uranium is radioactive and decays naturally. Many hypothesize that the radioactive decay of uranium with the release of particles of energy is one of the sources of heat in Earth's interior. This heat is needed to keep the outer core in the liquid state and drives the convection currents in the mantle. Uranium has been used for nearly 2,000 years as an additive to ceramics. Uranium is mined on almost every continent on Earth. This picture is a picture of a mine in Australia. And once mined, uranium is purified, and after purification it appears as a powdery cake. Einsteinium, always a fun element to talk about. Einsteinium is a synthetic intertransition metal named after Albert Einstein. Einsteinium has the atomic number of 99. It was discovered in 1952 at the University of California at Berkeley. A scientist was studying debris from a nuclear reactor and found an isotope of Einsteinium. The discovery of the element was kept a secret for several years because of the Cold War. To make Einsteinium, because it does not exist in nature, scientists start with a sample of plutonium. The plutonium is placed in a nuclear reactor. This results in the formation of a different isotope of plutonium, which is then mixed with aluminum and made into small pellets. The pellets are placed in 2 more reactors for over a year. The result is a mixture of californium, another actinide metal, and Einsteinium. The intertransition metals are unique elements for sure. The intertransition metals are composed of 2 series of elements, the lanthanide series and the actinide series. While these elements are, for the most part, not that significant commercially, they do exhibit properties of elements that are unique and interesting. Many of the intertransition metals do not exist naturally and are only produced in the laboratory.